Hey guys, this is Praveen. In today's video, we're gonna see about stack data structure using Python. So let's get started. So stack is something like we see in real world stack of plates. So you can see in this picture. The only important thing we need to notice is something like we can only add add the plate at the top of the stack or remove the plate from the top of the stack. We cannot remove it from a middle or a downside. We can only do it in top. So this is what the basic idea behind the stack. So here is an example with four numbers 28, 38 and 76. The name of the stack is num I given, and we can take only 28 and we can place only we can add it to add any number above the 28. So this is the basic idea behind this. So there are simply three main methods are there in stack. The methods are push, pop and peek. So push element will add to the stack, and pop will remove the last element from the stack, the top element from the stack, and peek will return the value in the top element. It's like a top node, we can say anything we want. So it will return 28 as the result. So you can see the picture like num dot pop will remove the 28 from the stack, and the rest will looks like 38 and 76 will be same, okay, after removing the 28. Then likewise push requires the input because we are pushing an element, a new element to the stack, so it requires data. So I given 90, num dot push 90 will push 90 to the stack, and the rest will looks like same, like 90, 38 and 76 will be the result. And num dot peek will return 90, just return 90 without removing or without adding, just it returns the value in the top of the top element. Okay, let's get started the implementation of the program. So now it's the implementation of stack. So basically what we want is something like a stack class, I mean, and the methods, as I already said, push and pop and peek, and the basic element like length of the stack, and we want to print it, so we want dunder string method to print it. So let's implement it. Like a stack, as you already know, class will be like a class stack. Oh, sorry about that, class will be lowercase, and it contains the first method of dunder init. It's like constructor, as I already said in the previous video. Self is the instance of the object, and we don't need any parameter inside or argument. So we need here is a list, Python list, so that we can implement stack. The data structure like a stack queue needs some initial data structure like a list array or a linked list, so that we can easily implement it. Without that we cannot implement anything in stack or queue. So we need initial data structure, so we use a Python list here. So self dot stack, I name it stack, that is equal to an empty list, okay. And to maintain the size of the linked list so that we can return the length, so I here doing the self dot size will be 0, and while we are adding we just increment it, and while we are popping we just decrement it, so that the size will be maintained. And the second method, it is push. Push data, we require data, so to push a new element. So we can here give an argument as parameter as data, and then how we gonna push it. We are gonna push an element or add an element to the last of the list, to the end of the list. Okay, if it's an empty list, it's the first element. If there is already an element, we just push it in the end of the list. Okay, it's normally self dot stack dot append, we can say. It's a normal method. Append data, or what data is given, we must append it. Okay, that's it. Then the pop method will be also easy because the Python list already contains a pop method, so we just gonna do the same. Pop requires no data, no arguments, so it's just a empty parenthesis. So self dot stack dot pop will remove the element from the last or top of the stack. Okay, then peek method will, without removing the element, we need the last element, right? So we use index, and we can do the same. Like peek also doesn't require any data, any argument inside. So self dot, we just need to return the data. So return the last element from the stack. So self dot stack of for the last element, we can use the negative indexing, like -1. So it will return the last data. Like, so len will be, we need to return the size of the stack. So we can use the dunder len method, as we said already in the previous video, so that we can use the len method easily. So we want to return the size of the stack. Return self dot size. Sorry, it's a attribute. Okay, we need to do something else, like we need to maintain the size. So here we increment the size because we are pushing the data, so size incremented by 1. Similarly, here we want to decrement it, size decrement by 1. Here we don't need to any increment or decrement because it's just peaking. Okay, the final method, the string method, double under string, dunder string method. We just need a string representation of the stack so that we can easily print it. So def double under string. Okay, it just return the string. So let's keep a variable like a result and empty string. Yeah, we just don't need to, because it's already a Python list, so we directly can print the result, can return the stack, because already the list will be printing like a string in the string representation. So we can just return the list, return the stack in our case. So it just returned the stack. Let's see how if it's working. Let me make sure there is no any error. So I'm going again, like first we are creating a class and dunder init method with the implementation of a Python list here, and we are maintaining the size of the stack, and the method is something like a push method is appending the data to the stack as it is already a list. So also incrementing the size by 1, and the pop method will remove the last element from the list. So we are using the pop method as it is a Python list, and size decrementing the size by 1, and peek method will return the last value without removing it. So we are using negative indexing to return the lost element in the list or stack in our case. And len method will return the size of the linked list, an integer, and string method will return the list or stack in our case. Okay, let's try it an example. Let's create a stack named, we name it stack itself, or as we saw an example like a num equal to new stack. Okay, here num dot, initially it has no elements, so num dot push will push the data inside. So let's push 70, and let's push a couple of elements like 58. Let me copy this so that we can. Okay, so let's push 2 and 30 here. Okay, let's print it. First let me print the length of the stack, so length of num. So why we are using dunder len method is something like we can use the len. If we didn't use the dunder len method, we can only use like this num dot push, like a num dot len. Okay, so for using this method, we just need this magical method like a dunder len or dunder string to print the list. So same for printing the stack. So print num will work. If we didn't give the dunder string, we can only print like this. For example, like print, we can only print like this. Okay, we cannot do the like this. It is done because of the this dunder string method. Okay, so let me erase this. Okay, let's check is it working or not. Oh, it's saying the error. Oh, it's saying it's a non-string type. Okay, as it's the list is a non-string type, so we just need a string representation. So we just erase it and make it as string. As we already said, we can create a variable like a result, and we can give the empty string, and using the for loop, while loop, we can here mention, or we can use the for loop itself because we know the length. So for I in range self dot size, because it's the size of the linked list, I mean size of the stack. So we need a string representation, right? So we just concatenating the string to this, like we can say it like a string of I, because we need a string representation as it is already int. So string of I will be the correct idea here, and we can append another more string like linked list, so that it will be visible correctly. We can separate the elements and see, so it will work. And finally we return the result, so it will work now. Let's see. Yes, it's working, but 1 2 3 is working because the I is the index of the element. So if we want I, we just need a something like a self dot stack of I. It's not just an I, because I is the index. Self dot stack of I is the element, so it will print. So let's check now. Yes, it's working perfectly. First we are pushing 70 to it, and 58 and 30 and 2. Okay, let's check the pop operation here. better here as num dot pop. So let's print it again here, print num here. Okay, let's check now. Okay, it's perfectly working. First we are pushing 70 to it and 50 to it, and printing the num here. Okay, and popping it like a pop will do the 58, uh, remove the 58 from the stack, and then again pushing 30 and 2. So final value is this. We are popping here, so 58 is not here. So it's working perfectly. If you practice it, you can easily do it. So if any suggestion there, please let me know that. I think sounds working perfectly. For the previous video, someone said audio is not that high. So thank you for the suggestion. So thank you for watching.